Hello, everyone. Welcome to our Friday YugabyteDB Tech Talk series. I'm Kannan Muthukkaruppan, co-founder at Yugabyte, and I have with me Premkumar Thangamani at Yugabyte to cover a very interesting topic. Welcome to our Friday YugabyteDB. Sorry about the echo. I had an audio out on another channel, so I muted that. So without further ado, let's get started. Prem, over to you for introducing today's topic and yourself. Thank you.
Thanks, Kannan. Good morning. Hey, folks. Hope you're all having a great day. This is Premkumar. I'm a technical evangelist at Yugabyte. Today, we are going to discuss various tips and tricks to improve the performance of your multi-region YugabyteDB cluster. We have about 7 topics to touch on. It's a little bit jam-packed session. So each topic in itself would warrant a separate talk. So no live demos today, but we will provide links to the demos and point you to additional information so you can deep dive into each of these topics yourself. Before we jump in, let's look at the spread of data centers from different cloud providers and understand why multi-region setup is not a trivial thing. So if you look at this, so this is the layout of different data centers from Azure, AWS, and GCP. As you can see, data centers are everywhere. Your users could be from different parts of the world, and you might want to put your servers closer to the users. But data centers might be just a ping away, but geographically distant data centers would bring in additional increased latencies. Let's see how we can get around the laws of physics. So first, we are going to look at the concept of preferred zones for leaders and see how it can help reduce latency in your applications. This is a standard RF3 cluster where you have your clusters split across multiple regions, 3 regions here. And the tablet leaders are distributed across the regions and followers are in each region. Let's consider your app to be in central for now. The app connects to any node in central. That node that it connects to orchestrates all the requests that the app is performing. And that particular node talks to all the leaders. Right now, in this example, if you can see, the app is connected to this node. It talks to the leader here. The green ones are the leaders, by the way. Leader in Central, US West, and US East. So consider a query which spans multiple tablets, or even a single row query where you're accessing a leader, and the index leader could be in a different region than the table leader. Wouldn't it be great if all the leaders are right together in the same region so that your app does not have to incur the cross-region latency? Because I have just put the estimates here, 60 milliseconds, but technically it could vary. So how do we do that? So we have a feature called preferred zones. Let's see how to use that. So you can set up the preferred zones using our YBadmin CLI tool. Right now, from this example, I've set it to US Central. You can also set it when you create the universe from our UI in the platform UI. And this can also be set after you had created the universe using the edit universe feature. The effect is almost instantaneous. It typically takes only less than 10 seconds to actually for the leaders to be new leaders to be elected, because there is no data movement. It's just that the replicas are already here, and the replicas are promoted to leaders. So now if you see, once we set the preferred zones for the leaders, all the leaders have moved to center. Now, your central app that has connected to one of the nodes does not incur any cross-region traffic because the node that it connects to orchestrates all the requests just within the US center. Even in the case where your app is in a different region, it has to incur only the initial connection request latency. After that, all the intra-tablet communication will be within the region. So this will be a huge latency boost for your applications. So because we don't have live demos today, I'm going to point you to a tech talk by Hari and Kannan, which was from YFTT episode 42. It's on YouTube. You can check that out. And if in case you want to go do step-by-step instructions for preferred leaders yourself, you can look up at our documentation.
Yeah, and if I could just make a comment on the previous slide, Prem. So yeah,
Yes.
first off, thanks, Prem, because I mean, I just wanted to re-emphasize that today we're going to cover like a whole bunch of tips and tricks for multi-region deployments. Like Prem said, on each of these topics separately, we have given YugabyteDB Friday Tech Talks, but we were hoping to consolidate and in a single talk these pointers to various ideas so that you have a good reference point to start from when you're starting to look at how to optimize a multi-region deployment. In some of these configurations, there are also trade-offs. Like you may say, like, hey, if preferred leaders, if picking a preferred zone for your leaders makes sense, why is this not the default, or why, and so on? Is there a catch, right? So maybe Prem, do you want to talk about, like, is there any disadvantage of doing this?
For example, if in case you have your app in different regions, it has to still go to a specific region. So that is the primary disadvantage I can see.
Yeah,
and
maybe one thought I wanted to mention was there is a trade-off here for read-heavy workloads. Now, if you want strongly consistent reads, then you're only utilizing the resources of one for the US central nodes, right? That is one trade-off here. If you want strongly consistent reads and you're setting preferred zones, then while you're reducing the latency of your application, you are not utilizing the resources in the other data centers to some extent. So that's a point worth thinking about.
we are going to touch upon the consistent reads in the future slides.
Yeah,
Yeah,
and that has different trade-offs. So yeah, let's keep.
Okay. All right. So those are your links to demos and documentation. Now let's jump into another topic, failover reads, which is, as the name says, it's basically reading from the followers. One of the foundational features of YugabyteDB is strong consistency, and followers may not be up to date. There would be some scenarios where it would be greatly helpful to read from the followers. Let's look at a few of them. So consider this scenario where you have set up preferred leaders in Central, and your app is talking to Central. Everything is fine, you have good latency. But think of an application that has to do daily reports on your data. It does not need the latest data. So it would be okay for it to read from followers because it's okay to deal with stale data. Or it could be a resource-intensive application where you want to do workload isolation. So you want that particular application to run in a different region. So, but it has to go to cross-region to look up the data from the leaders. This feature can actually be useful for reference table point lookups or config changes where the data does not change much. So a few seconds delay might be okay. We can avoid the cross-region traffic by setting up failover reads. Let's see how to do that. First, the transaction should be read-only because all the writes have to go to the leaders. And you have to turn on the feature flag, which is YB read from followers true. Once you set both these options, now your selects, which are basically read-only selects, where select star from users where name is John Wick, will automatically go to followers. Let's see the effect of this. So your leaders are here in Central, but still the reports app is able to now go for the select query, a read-only transaction query to the local followers. So remember, your writes will still go to the leaders. So as long as the small staleness is okay for the application, this would be hugely useful for your application. It's a great latency saver. Amit Anand did a great tech talk with Kannan in the 7th episode of YFTT, one of the earliest episodes. And so that is on YouTube. You can check that out. If you want to do step-by-step instructions for you to play with, you can check out our documentation. Let's jump into tablespace. It's an interesting concept from Postgres. So in Postgres, tablespaces define where the data is to be stored. Like, for example, if you have a table that is very big, you would want to put it into a bigger disk. If you want to have a fast table, you might want to put it in an ultra fast disk. So that is what tablespaces are used for in Postgres. Yugabyte extends this concept to a distributed database. Here, tablespaces allow you to define where the tables and indexes attached to the tablespace are to be located. Let's see with an example. Let's say you have your data has of people from US and Europe, and for GDPR, you expect the data of European users to be in Europe at the same time, US users to be in US. For this example, we are going to split that into 2 tables, and then we'll explain other optimizations in the later slides. So what we want to do is you want to split the user table into 2 different tables and place the users of European users in Europe and US users in US. Let's see how to do that. So first, you create a table space for Europe and specify the placement blocks to be just the European region data centers. So here I specify West, East, Central of just EU. So any table that is attached to this table space Europe will be placed in Europe only. So even the replicas and the leaders will be there right there. And when you create the table, European users, you attach it to the table space Europe. So similarly, you create a table space for US and specify the regions, US regions, US West, US East, and US Central, thereby making sure that the leaders and the replicas will be placed in US. So when you create the US users table, you specify that it is going to be attached to the table space US. Now, automatically, all the user data for US will be in US and European users will be in Europe. Let's see how that works. So here now the US users table has leader in the US data centers and the replicas also are placed here. And the European users data is right here in Europe. So you have Harry Potter in Europe and John Wick in US. Feel free to ask any questions in the chat and we'll answer.
There's one question, Prem, on the previous topic. When you said preferred zones to a particular region, would it make sense to have larger nodes in that region?
So that is what actually you had touched upon, because it's going to read all the load is going to come to that particular region. But it is going to be difficult to manage if you change your configuration for provisioning, and if you have few machines of a different configuration. So we suggest, this is what we suggest. We suggest, depending upon your traffic that or throughput, you want to have all your machines on the same type. Because the problem is when you have a failover, if the region fails, then your loads are automatically going to go to a different region. And if that region is under provision, you will have a bigger problem. So it's better to actually properly estimate your provisioning capacity and then appropriately do this.
That's exactly right. Like, because you have to plan for the failover case, you can't quite get away with just one zone or one region having larger nodes. One suggestion is, in a 3-region topology, maybe 2 of the regions at least have to have similar size nodes. And in the set preferred zones command, you can actually give a fallback sequence. You can say region A is my first priority for leaders. If that region is down, region B is my second priority for leaders. So, and if you have to basically plan for one region failure, then at least 2 of the regions out of 3 need to have these larger set of nodes. Yeah, let's keep going, Prem.
Okay, so Frank Pachot, our developer evangelist, he did a great tech talk with Kannan previously on YFTT. You can check out that video on YouTube. He deep dives into how Tablespaces. He comes from a humongous Postgres background. He's our Postgres expert, so he talks much about Tablespaces. You can go do a step-by-step.
He actually comes from a deep Oracle background.
Oh, Oracle. Okay.
He's become a Postgres
expert. Okay, so you can check out our documentation for step-by-step instructions. Now we looked at table spaces when we show the example where you can split your user table into 2. But it is difficult to manage a scheme of one table of users into 2 with US table and Europe table. Your application would have to change to query 2 different tables, but can we maintain a single table across 2 different geos and place just the user rows separately, so that your application should actually see just one table, but the rows would have to be placed in different places. Let's see how to do that. So this is what we want, right? Initially, we said that US users are located here, European users are located here, but instead of talking to 2 different tables, it would be great if the application just talks to one table users. Let's see how to do that. So what we have to do is you create 2 different table spaces as before. And You specify the European regions for the Europe table space and US regions for the US table space. But when you create the table users, you are going to define the table to be partitioned by list. So you're going to say that by a specific column, move the rows to a different region. So that, for example, let's say that the column geo has values, country values, which is US, Europe, or India. And depending upon these values, your rows will automatically move. So now that is the actual parent table. Now you're going to create two child tables. We call it partition tables. So create table US users, partition of users. So it is a partition of users. So automatically you're saying that parent-child relationship there. You give the same schema as the parent table. And then for values in US, attach it to table space US. So this is, we already said that partition by list geo. So it automatically knows that this US is to be connected with the column geo. For all the values of US in column geo, the data will automatically move to US users. Similarly, for European users, you create a separate table, and for all values of geo with values EU, it will move to EU users table. Because you're attaching it to the different table space, the table will be placed in a different location. Let's see the effect. Now it's the same way. Now the tables are located here. The child tables are located here, but it's just a single table. Actually, logically, it's a single table, but physically, it's two different tables. And you can directly query the users table. You don't have to query the US users or EU users table, but all you have to just query the users table and it automatically go to the right place. There are some certain tips and tricks on how you can optimize your queries. We are not going to go deep into that because of our time limitation here. So I'm going to point you to the tech talk from Deepthi and Kannan, where they go into row-level geo-partitioning in detail. And if you want to do it yourself, step by step, in section or in our documentation. Any suggestions, Kannan?
No, that's good. I think you're covering at a good speed because
yeah. So next is covering indexes. So first, we create indexes to make our queries fast. But when the index does not have all the data for the query, it would have to go to the table for other columns. So typically, this is known as an index scan. We can use covering indexes to skip that trip. So that will become an index-only scan. Let's see how to do that. So for example, let's go over the users table, which has ID, name, and city for every user. And you create an index because you want to, on the user's name, because you want to look up information based on the name of the user. Say, for example, select ID, city from users. That name is John Wick. So you have the index here, you have the users here. I'm just, for the sake of example, I'm just showing you one region. The app connects to the index because it's doing, you have created the index, the optimizer will automatically say that it's an index scan. It'll go to the index, it will figure out the row for that, quickly figure out John Wick's row. But to get the ID and city, it has to go to the users table. That is an additional hop. So we can avoid that by using covering, by defining this index to be a covering index. It's very simple. So index, all you have to do is include the ID and city when you define the index. So index IDX name on users, include ID and city. This automatically becomes a covering index. So now when you execute this query, select ID, city from users or star from users where name is John Wick, it will go to the index first. And because the index already has all the data of for John Wick, ID and city, it does not have to do the additional trip here. So this now becomes an index-only scan. So this is much faster than the index scan because you skip, especially in the multi-region scenario where your index leader and the tablet leader could be in different regions. This would be a great latency improvement.
Again, Prem, it might be worth calling out the trade-off of using covering columns or covering.
Yeah. So of course, every time you add a row for large rows, you're going to incur the additional storage for every write has to be, data should be written in two places now. So that is the problem. So more covering indexes you have, more writes, the writes are going to be larger for.
Yeah, basically these included columns are duplicated both in the main table and now in the index. So there's you're trading off some space, but often And yeah, that's the trade-off. As long as you're aware of the trade-off and what you get from it, you can make the choice.
Yeah. So most of the topics that we are discussing today are basically improving the speed of reads. So
Correct.
at the cost of sacrificing the speed of writes. So another tech talk by Frank with Karthik in the episode 12 of YFTT. So they deep dive into covering indexes. That feature has not changed much. It's still solid. And you can, if you want to learn more about covering indexes yourself, you can check out our documentation. So now we have learned about tablespaces. Now we have learned about covering indexes. That is a very interesting concept called duplicate covering indexes, where you can get consistent reads from a local region. It's an amazing concept. It's a lot of things can be done. It could become our flagship feature at Yugabyte. So it's almost nothing short of magic. So let's see. So consider this scenario where you have apps in different regions. We have already discussed preferred leaders, where you automatically your index and tablet leaders are in one region that we set up with preferred leaders. Now your apps are coming here. We discussed covering indexes. So this is a covering index. So it does not have to go to the main table, right? So that's all done. Now, so wouldn't it be great if we have a covering index right here? Because we have a replica here, and here. But you cannot read from replicas because the replica, you have to turn on failover reads. Now we are going to introduce a concept where you can have multiple indexes here and here using table spaces, a trick with table spaces. So your app can actually do an index-only scan right here. Let's see how that works.
Yeah, I mean, just to re-emphasize the point that Prem is making, yes, there are copies of indexes in other regions, but like he said, but then you would have to use follower reads, and the real catch with follower reads is that you are not doing strongly consistent reads. So how do you kind of defy the laws of physics if you want strongly consistent reads and yet read from your local region, right? That's the problem statement. So go ahead.
Yeah. All right, so what you do is you create 3 different table spaces for each region. So US West, 1 table space for West, and then make the leader preference to be West. And similarly, create a table space for East and Central and set the leader preference to be Central and East. So see, this is not a region only table space. It is still a multi-region table space because I'm placing the replicas in US East and Central, even for the West table space. I'll touch upon the topic a little bit later because it's very critical. Now, when you create index, now what you do is you create 3 different indexes. Index West, East, and Central. So, and attach it to the table space West, East, and Central respectively. Now, let's see how that works. Now, Index West will have a leader here. Index East will have a leader in East. Index Central will have a leader in Central, which are all covering indexes. Now, because it's a covering index and it is a leader, it is immediately consistent. So your app can actually read from the local index. Now, in Yugabyte, all writes are immediately reflected on the indexes. So they are all the writes are synchronous, index updates are synchronous and transactional. So now that is where the comment, when you have a write to a user table here, it has to update this index, and this index. So that is the cost that you're going to pay. Your writes are going to be slow to make your reads are super fast. At the same time, let's say that because you have 3 indexes attached to your table now. Now, think about the case where this region fails. If this region fails, this index, if it is just a local region, if you had placed the replicas for this region of this index, right in this region, all the replicas and the leaders will be lost. Then all your updates, your writes will fail because the update cannot be made to the index. That is why it is absolutely important when you do duplicate covering indexes, you have to place your replicas on multiple regions.
Yeah, if you go back to the previous slide, the point is that if you look, so firstly, this table space concept is something that applies not only to tables, it applies to indexes also. So that's point number 1. Point number 2, as shown, all 3 indexes are still multi-region because we want high availability for these indexes, both for writes and reads. We don't want a region being down to make writes fail. So that's why all 3 regions That's why they're kind of duplicates. They're all multi-region. They're all indexing the same set of columns. But the only difference is for West, the leader preference is set to US West. And then for the other two table spaces, you will set the leader preference to US East and US Central respectively, right?
Yeah.
And you're taking more penalty on the right path, but on the reads, maybe it's worth mentioning, Prem, that your app doesn't have to do anything different. Your app can still say, give me the row where name equals John Wick or something. That was your example, right?
Yeah.
And the magic is in the query optimizer, which automatically recognizes the region the app is connected to and has the right cost model saying for this query, although I have 3 candidates indexes to use, I know I'm going to use the index West because my app is connected to West, right? So that intelligence is in the query optimizer. But it's worth calling out, Prem, I don't know which, can you confirm which release? That's a relatively newer feature, right? The query optimizer.
Yes. So for the optimizations for the query optimizer to pick the best index for these cases is in the current master 217.3. So
okay.
you can check it out.
Recent,
fairly recent.
Yeah. Go ahead.
All right. All right. So we don't have a full-fledged demo for this, but Frank has an amazing blog on this particular topic. You can check out our documentation or covering indexes. Have to move fast because this is the last topic for today. Smart driver. Let's look at some of the advanced load balancing and failover mechanisms you get for free when you use our smart driver that's given by Yugabyte. So typically, when you have many nodes, it's natural to route your requests through the load balancer, through an external load balancer like HA Proxy, Nginx, or Varnish, which are pretty fast to make your app request spread across all the nodes, not just the one that app connects to. For this, you need an external load balancer, as I said, for Varnish or Nginx. They're pretty fast, or some cloud providers provide NLBs, which are quite fast, but still an additional hop, right? Your request has to go to the load balancer and then go to your nodes. The problem with the external load balancer is that it may not know your topology of your cluster. Every time you add and remove a node from YugabyteDB cluster, you will have to update the configuration of your load balancer. So for this, Yugabyte actually provides a very cool product called Smart Driver. Let's see how that goes. So when you connect to a node, you give a connection string, and the connection string can take a set of options. In the options, all you have to set is load balance to. It's as simple as that. So note, you're just giving one IP. When you give that IP to the smart driver, just one IP of the node, one IP of your 15 node cluster, and it connects to the node's master server, fetches the list, the whole topology of your cluster setup, and then knows that you have 15 nodes. And distributes your connections across all the 15 nodes. But let's say that you don't want to connect to all your 15 nodes. You have leader preference set to central. What you can do is you can set your topology keys to central so that your application will only talk to central. And say you want to have failover. Let's say that you have set your leader preference to central and then west. Similarly, you can specify your keys here such that first it will connect to central, and in case central fails, it will automatically switch over to west. Let's see how that works. So now, once you have your smart driver, this is an app with a smart driver, it directly connects to the nodes. So the smart driver refreshes the node list. So anytime you add a node or remove a node, it keeps that list of nodes updated. So it automatically moves the connections. So let's see how failover are done. Now, let's say that all the nodes that you initially connected to from central fail, or there is a region outage, a power outage, or a disaster. Immediately, your app switches over to your west because that's what we had configured in our topology keys when we did the connection. It's very simple. All you have to specify is just one node in the 15 node cluster, and then it automatically figures out everything that you would actually spend time setting up an external load balance and everything. So this is a great time saver. Just one thing is that all these are nodes compared to all the tablet leaders that we talked in the previous examples. So Neeraj gave an amazing tech talk on this. It's his team which develops a smart driver. You can check that out. We have a lot of documentation related to smart driver. We have smart driver in 5 different languages: Java, Go, Python, Node.js, and C#. please make sure that you play with those things. That's the end. Hope you guys learned something new today. Adopting some of the tips discussed today will have a huge impact on the performance of your multi-region cluster. Check out the demos, mention the links. You can also check out our code base on GitHub to see how the features that we discussed today are actually implemented. It's so cool. Reach out to us on Slack if you have any questions. Feel free to share your experiences on how you improved your cluster's performance. Thank you. That's it. Any questions?
That was awesome, Prem.
We did it time.
Yeah, I wasn't. There have been other talks where we went 5 to 7 minutes over. I thought this would be one of them since you're covering like 7 or 8 subtopics, but I think you really planned it well. Fantastic illustrations as well. So fun. I had fun hosting this one. Yeah. And thoughtfully put together set of topics. So thank you, Prem, and thanks everyone for joining us this Friday. See you all on another episode of Friday Tech Talk next week. And over to you, Prem.
Thank you all. So if any of these tips are useful, just let us know how it was useful or the pain points that you face in setting these things up. Do check out our demos. Thank you. Have a great day.